What is IBM Db2? Think about it for a second. Imagine a world where the data behind your bank account, your flight home, or even your weekly grocery run just vanished in an instant. I'm talking about a world where data is chaotic, messy, and basically untraceable. Now, we don't have to imagine that, because back in the 70s, IBM kicked off a revolution. They didn't just build a database, they birthed the very idea of a relational database, and that led to their most powerful and long-lasting champion, IBM Db2. Today, Db2 isn't some dusty piece of legacy software, not at all. It's a high-performance, AI-driven powerhouse that's actually running the world's most critical systems, from massive global banks to the latest cloud-native startups. In this video, we're going to peel back the layers of Db2. We'll look at its incredible history, its rock-solid architecture, and some of the cutting-edge stuff like BLU acceleration and integrated AI that keeps it at the very top of the pile. So, whether you're just starting out in data, you're a seasoned admin, or you're a decision maker planning your next big move, you're in exactly the right place. Let's dive into the ultimate guide to IBM Db2. To really get Db2, we've got to go back to 1970. That's when IBM researcher named Edgar F. Codd published a paper that changed everything. It was called A Relational Model of Data for Large Shared Databanks. See, before Codd came along, data was stored in these rigid, complicated structures. If you wanted to find one piece of info, you literally had to follow a physical path on the disk. It was slow and it was painful. But Codd had a better idea. Store data in tables, relate them with keys, and make them accessible using a mathematical language. IBM's team in San Jose took that idea and ran with it. They started System R, and that is where SQL, or Structured Query Language, was actually invented. Then, in 1983, IBM officially launched Db2, short for IBM Database 2, on its mainframe platform. It was the first time anyone had built a relational system that could truly handle massive, global-scale workloads. Over the next 40 years, Db2 just kept evolving. By the 90s, it moved on to Linux, Unix, and Windows, the version we now call Db2 LUW. Today, Db2 is in this unique spot. It's one of the oldest RDBMS platforms out there, but it's also one of the most innovative, with native support for things like JSON, XML, and even vector data for modern AI. So, how does it actually work? Well, Db2's architecture is basically a masterclass in stability. At the center of it all is the database engine. It handles everything from storage to security. But the real secret sauce is how it manages memory and I/O. Unlike a lot of simpler databases, Db2 uses something called buffer pools. Think of these as a massive VIP waiting room in your RAM. When you query data, Db2 doesn't just go digging around on the slow disk, it pulls it into that buffer pool. So if you need that data again, it's served up instantly from memory. Then there's the logging system. Every single change, and I mean every single one, is written to a transaction log before it even touches the disk. This write-ahead logging is what makes sure that even if the power cuts out mid-transaction, Db2 can recover every single byte. No data lost, period. Now, for you administrators out there, the most powerful tool in your kit is the Query Optimizer. Whenever you write an SQL query, the optimizer looks at millions of possible paths and picks the absolute fastest one. It's like having a world-class navigator for your data. And in the newest versions, that optimizer is actually AI-powered. It learns from every query you run, so it gets even faster over time. Now let's talk about pure speed. In the world of big data, traditional storage can get really sluggish. Imagine you're running a huge report on total sales. A traditional database has to read every single column in the table just to get to that one sales amount. That's a huge waste of time. That's where IBM BLU acceleration comes in. BLU flips the database on its side using something called columnar storage. Instead of storing data by row, it stores it by column. So when you run that sales report, BLU only looks at the sales amount column and just skips everything else. We call this data skipping, and it can cut down your disk work by 90% or more. But here's the cool part. BLU uses actionable compression. Most databases have to unzip data before they can read it, which burns up your CPU. But DB2 is smarter. It can do math and comparisons directly on the compressed data. It's incredibly efficient. And finally, BLU uses parallel vector processing. It breaks your query into tiny pieces and runs them across every core of your processor at the exact same time. The result? Queries that used to take hours now finish in seconds. We're talking about a massive, generational leap in performance here. For anyone in a decision-making role, downtime is the scariest word in the book. If the database goes down, the business stops. Simple as that. IBM fixed this by bringing mainframe clustering technology over to distributed systems. They call it DB2 pureScale. Most clusters rely on a backup server that has to wake up if the main one fails. That's too slow. DB2 pureScale is active-active. Imagine a whole team of servers working together as one single database. If one goes down, the others just pick up the slack. Your app won't even notice a blip. What makes pureScale different is the caching facility and remote direct memory access, or RDMA. Usually, when servers talk to each other, they have to go through the operating system's network stack, which adds delay. But pureScale bypasses the OS entirely. Servers talk to each other at the speed of hardware memory. It gives you unlimited scalability. If your business hits a sudden spike in traffic, you don't need to rebuild your server. You just plug in another one. DB2 detects it and balances the load automatically. It's exactly why global stock exchanges trust it, because failure just isn't an option. DB2 definitely hasn't stayed stuck in the past. Over the last decade, it's aggressively moved into the cloud and AI era. Today, you can run DB2 on cloud as a fully managed service on IBM Cloud, AWS, or Azure. It's the same heavy-duty engine, but with the convenience of zero maintenance. You get automated backups, patching, and scaling, all at the click of a button. Then there's DB2 Warehouse, which is built specifically for massive petabyte-scale analysis and data science. But for me, the most exciting part is the artificial intelligence. Modern DB2 uses machine learning right inside the query optimizer. It doesn't just guess the best path anymore. It actually learns from every query you run. It builds a neural network model to get smarter and faster as you use it. On top of that, DB2 now supports native AI data types, like vector storage. This is huge for building modern generative AI applications. You can store your AI embeddings right next to your business data, so your AI has the most accurate context possible. And even with all this new tech, security is still the top priority. Features like end-to-end encryption and data masking, where sensitive info like credit card numbers are hidden automatically, make DB2 one of the most secure platforms on Earth. It easily meets the toughest standards like GDPR and HIPAA. So, why does DB2 still matter when there are so many other databases out there? It matters because it's the gold standard for reliability. It's got 40 years of engineering excellence backed by the most advanced performance features available. From the birth of SQL to the new frontier of AI, IBM Db2 has stayed at the front of the line. If you need a database that effectively grows with you from a single laptop to a global cluster, Db2 is your answer. If you found this guide helpful, hit that like button and subscribe for more deep dives into tech and data. What's your experience been like with DB2? We'd love to hear from you in the comments. Thanks for watching, and I'll see you in the next one.